Section 2.4, Increasing, Decreasing, and Piecewise Functions. Let's start with some definitions. A function is increasing on an open interval if the graph rises from left to right. So here is an example of a graph that when we start at the left end and we move towards the right, it is going up. We say that it is increasing. Another word in math used for increasing is rises. From left to right, it rises. A function is decreasing on an open interval if the graph falls from left to right. So look at this graph. If we start on the left and we travel towards the right, it is going down. We say that it is decreasing, or it falls from left to right. A function is constant on an open interval if the graph is horizontal from left to right. So for this example, we start at the left and we travel towards the right. We're not moving up, we're not moving down, we are staying constant. So a horizontal line is considered constant. Notice that all of these definitions use the phrase open interval. So when we write these intervals from looking at the graphs, we will always use parentheses. Open means parentheses. Closed would be square brackets. And the reason for that is because when we are actually at one end or the other, we're not increasing or decreasing. So you have to have a range of points to be increasing or decreasing or even constant. And thus we should always use parentheses, never square brackets on these problems. And that's stated here on this slide. It also says always use x values. That's important. So when we list these intervals, we will give the x values. It doesn't matter what the y is. We are only looking at x, kind of like when we were looking at domain. But notice in all of these intervals, they're all parentheses. Even though when you look at this graph, you see some closed circles, when we're giving domain, we have to decide whether to include those endpoints, and a closed circle means square brackets. But that is totally different here. We are only talking about the range, the interval, not including the endpoints. So we will always use parentheses. Okay, so with that in mind, let's focus on this graph. We're going to start at the far left, and if we start traveling towards the right, we're going up, we are increasing until we get to this point. And so look at the x values for that interval. This leftmost point is at -5 on the x, and it increases all the way to here, which is at -2 on the x. So when we write the interval for that, it would be -5 to -2. And we're just going to keep going left to right. So now I'm going to pick up with -2 where I just left off. That means the next interval starts with -2. And we travel to the right. It's staying constant until we get to this point. So look at the x's from -2 to 1 on the x. The graph is constant, and so that's where this interval comes in. And then the next one we'll pick up with 1. So we go from 1, we travel to the right, we're going up, we're increasing until we get to this point. And now we're looking at the x's from 1 to 3. It is increasing. And so we would write this interval down. And then the last interval from 3, and then we're going down all the way to this rightmost point on the graph. It's at 5 on the x. So from 3 to 5, it is decreasing. And so you can count how many intervals you're going to have in your graph. You could say, okay, 1, 2, 3, 4. I should have 4 intervals. And another thing to pay attention to is that where one interval ends, another one should begin. So when this one ends at -2, then there should be an interval that starts with -2. This one ends at 1, then we need another interval that starts with 1, and so on. Okay, let's try some examples. The instructions say, use the graph to determine the intervals on which the function is increasing, decreasing, constant. So in our first graph, it has arrows on the ends. Sometimes there will be arrows and sometimes there will be endpoints. So if we tried to start at the leftmost point of the graph, well, we wouldn't really be able to pick that leftmost point. So we just start somewhere, it doesn't really matter where, over on the left. And as you go towards the right, you can see that the graph is going down. It's decreasing. Let's label that, decreasing. All the way until we get to this point right here, okay? And then, as we keep going right, now it is increasing. It's going up. Increasing all the way until we get to this point. Then it turns and it starts decreasing again. So there should be 3 intervals in our answer. So decreasing first, and the leftmost is -infinity. So that interval is going to start with -infinity. And then it's going to decrease all the way to this point. Now remember, we're giving its x value, and the x value of that point is -2. Okay, next interval is increasing, and it starts with -2 where we just left off, and it's going to keep increasing all the way to this point, and look at its x value is 1. So -2 to 1, and then from 1 to forever, it is decreasing. So we're going to put a second decreasing, just put a comma, and then another interval here. And it's starting with 1 where we left off. And it keeps decreasing forever, so we would put +infinity. There are no constant intervals in this graph. So for constant, go ahead and write none. If it helps you to kind of maybe draw a vertical line through the points where the graph turns, you could do that. I can't do it very well with this pen. It doesn't allow me to draw very straight, but certainly if you wanted to, you could kind of draw it through there. Draw it through there. And so then just look at your x's. So from -infinity all the way to -2, then from -2 to 1, and then 1 to +infinity. Just make sure you concentrate on the x-axis. And also make sure you're using all parentheses. Okay, graph number 2 has endpoints. They're closed circles. They're kind of small, so you may not be able to tell very well, but this is a closed circle and this is a closed circle. So let's go ahead and label before we start listing our intervals. And we start here at this left point. As we go to the right, we're going up. We are increasing until we get here. And then, as we continue to the right, it's now going down, so it's decreasing till we get to this point. Then the graph stays horizontal, which means it's constant from this point to this point. And now it increases until you get to the rightmost point. Okay, so let's start on the left. Our x value is -5. So we're going to start with -5 and we put that under increasing. -5. And it keeps increasing to this point. Look at the x there is -2. Even though these are closed circles, I am using parentheses, okay? Every time when I give increasing, decreasing constant, I use parentheses. Doesn't matter whether the points are open or closed. Okay, so as we continue to the right, now we're decreasing. We're starting at -2 where we left off. And we're decreasing until we get here, and that is x equals +2. So -2 to 2. Okay, at that point, as we continue to the right, it's staying constant. So starting with 2, and just a short little interval from 2 to x equals 4. The graph is constant. And then we have one more interval. From 4, where we just left off, it is increasing. So we're going back up here. We're going to put another increasing. And it only goes 1 unit to the right. From this point to this point, only goes from 4 to 5 on the x-axis. 4 to 5, just from here to here. And we have 1, 2, 3, 4 intervals in our answer. Okay, we're going to go ahead and practice a couple more. These graphs look a little different than the first two because they have breaks in them. They are actually called piecewise functions, and we will talk more about those in the second video. But as far as the graphs go, even though the pieces are not connected, it still picks up at the last x value. So if I start at the left, I'm going up, I'm increasing here, and then I stop, and I have to jump up to here, but it still picks up at that same x value, which is 0. And then it's constant, just in that 1 unit interval there. And I pick up still at 1. So my x is still 1 for the new interval, and it is increasing again. Okay, so remember, it doesn't matter whether these circles are open or closed, we are using parentheses. So our first interval is increasing, x is -3, and it increases all the way to here where x is 0. Then we have our constant interval, which picks up at 0, and just 1 unit from 0 to 1 on the x-axis, it is constant. And then our last interval picks up with 1. It's increasing again, so we're going back up here to increasing. 1 increases all the way to 4 on the x-axis. So just 3 intervals. It is not ever decreasing, so let's put none for decreasing. Okay, look at number 4. It also has arrows on the end like number 1 did. It does have some breaks in it, but at each break, the graph picks up at that same x value. Let's go ahead and label. So I just start somewhere over here and I go towards the right. The graph is decreasing all the way till we get to this point. Then it turns and it starts going up. Just for a short interval there, it is increasing. And that one you have to be careful on. This interval here is one that I see a lot of students miss when they're doing problems like this. Okay, then up here we've got a constant interval. And the last interval from left to right is going up, is increasing. So 4 intervals for this problem. We'll start at the left. We have our decreasing interval, but we do not have a leftmost point, so we're going to say -infinity. And it decreases down to here where x is 0. Then we've got this small little increasing interval that starts at 0 and increases until x is 1. When x is 1, we're going to jump up here, and we have a constant interval from 1 to 2. 1 to 2 on the x. And then at 2, it starts increasing again, so come back to increasing 2, and then it increases forever to positive infinity. Okay, so that takes care of increasing, decreasing, and constant. Something that goes along with that would be relative maxima and minima. These are the plural forms of maximum and minimum. You can think of maxima as peaks and minima as valleys. The peaks are the high points, the valleys are the low points. So if we look at the graph on this slide, the first point we see here, A, is called a relative minimum. Relative minimum means it's the lowest point in some open interval. So in just this little piece of the graph, that point is lower than the points around it. And that's called a relative minimum. There can be more than one. This is also a relative minimum. It's a low point in that interval. And this is a relative minimum, another low point, A, C, and E. Now, you'll notice that for C, it's called an absolute minimum. The absolute minimum is the very lowest point of the entire graph. We're not really going to worry about using that term absolute, but just to let you know for future information. Right now, we're just going to name all the lowest points as relative minimum and the high points as relative maximum. So B would be a relative max and D. Those are high points in the interval around them. Now notice it doesn't even say absolute max, and that's because really this should have arrows. It keeps going up forever, so it doesn't have a highest point for the whole graph. Okay, let's read this sentence at the bottom. The relative maximum or minimum is a y value that occurs at an x value. So that's going to help us know how to write our answers. We're not going to just write the ordered pair. We need to make sure that we know the actual max or min is the y value. And then we will go ahead and tell what x it occurs at. It should make sense that the y value is the max or min because you're talking about a high point or a low point. And when you talk about high and low, then we need to be thinking of y values. Left and right would be x values. Okay, so let's see some examples. Number 1 should actually have arrows on it, so you can go ahead and draw those. So we're just going to look at this graph for any high points or low points. Another way of thinking about it is anytime the graph changes from increasing to decreasing, that turning point there, that would be a relative maximum. And then it starts decreasing all the way to here and then increasing. So it's changing. Decreasing to increasing makes a relative minimum. Now, how are we going to write it? You can abbreviate, so we'll say relative max. And you can put is, or you can just put a colon if you want. I think in the homework I used a colon. And we're going to name that max. So we're naming the y value of this point, which is 2. You don't have to say y equals 2. You can just say 2. But then we're going to say at x equals, and then we give the x value, -1. So that high point of 2 occurs at x equals -1. That just tells us the left-right number. Okay, now we also have a relative minimum. We have a valley. We have a peak and a valley. So we're going to write relative min. And we're going to name its y value, which is -2, at, and then we give the x value is 1. So this is how I want you to write it, not as an ordered pair. And sometimes there could be more than one, max or min, or there might not be one at all. Like number 2 has a low point. This is the low point. And even though it actually is the very lowest, it would be the absolute minimum. We are just going to call it a relative minimum because that's all we're working with right now. And we're going to give its y value is 3 at, and then we look at the x equals 2. And there is no high point. It just goes up forever. So it only has a relative min. Then you can just box that in as your answer. You don't have to say no relative max. Okay, so I'm going to go ahead and stop the video here. And the last topic, the piecewise functions, I will cover in the second video.